The following is the details and objectives of this course. Please read it carefully and start the course. The Euro regulations were established in Europe in 1992. They have been strengthening exhaust gas emission standards in phases, starting with Euro 1. In 20 years, the regulations have achieved significant reduction of NOx and PM. Euro 5 has stricter emission standards than Euro 1, 2, 3, and 4. To comply with such strengthened emission regulations, many systems, for example, EGR, LPEGR, and DPF, have been developed and are continuously being advanced. The EGR system reduces NOx by controlling the amount of EGR gas. NOx formation can be suppressed by lowering the combustion temperature. The main components of the EGR system include the EGR valve that supplies combusted gas to the intake based on ECU control, the EGR cooler that cools the recirculated exhaust gas, and the bypass valve that directly sends exhaust gas to the intake without passing through the cooler during cold conditions. There are three types of EGR valves. First, the vacuum EGR type. It was used in the early versions of the common rail engine. The second is the solenoid EGR valve. The third is the DC motor EGR valve that uses an H-bridge circuit. The DC motor EGR valve has high drive torque, and this prevents the valve from being stuck in an open state by carbon, which was a problem in previous types. When you look at the data in the GDS, you can see that the EGR operates for about 1 minute in idle state after acceleration. The intake airflow value when the EGR is not active is 385 milligrams per stroke. And when the EGR is active, intake airflow value decreases. The EGR cooler lowers recirculated exhaust gas temperature by coolant. If the EGR gas temperature is lowered, the density of the recirculated emission gases becomes higher, and the efficiency of the EGR system increases. In addition, the EGR cooler cools high-temperature gases to prevent knocking and improve fuel efficiency. Another merit is that the EGR system can be smaller in design. The low-pressure EGR system is a technology applied in Euro 5. In addition to the existing EGR, the system includes an additional LP EGR system. From now on, the previous EGR will be referred to as high-pressure EGR. When you look at the EGR gas flow, high-pressure EGR gas passes through the exhaust muffler, high-pressure EGR valve, and high-pressure EGR cooler, and then flows back to the intake. In contrast, low-pressure EGR gases pass through the exhaust muffler, DOC and DPF, the exhaust pressure control valve, the emergency filter, and the low-pressure EGR cooler, and then flow back to the intake. In the previous high-pressure EGR gas is recirculated between the exhaust manifold and turbocharger turbine. This had the potential problem of reducing the pressure supplied from the turbocharger turbine. But, unlike the high-pressure EGR, the low-pressure EGR recirculates the clean exhaust gas with a low temperature and a low pressure from the rear of the catalyst filter into the intake. As a result, it became possible to recirculate the optimum amount of fuel according to driving conditions while improving the NOx-reducing effect. In addition, the pressure supplied from the turbocharger is not affected by EGR operation, increasing turbocharger efficiency and maximizing fuel efficiency. When you look at the EGR system's operation range, the exhaust gas is recirculated through the HP EGR valve in low load range, and both the HP EGR and the LP EGR systems are controlled in the mid-load range. Then, in high engine load range, the LP EGR system controls more of the gas flow than the HP EGR, regardless of engine RPM. The reason is, if high-temperature exhaust gas is recirculated in high load range, a large volume of NOx is generated, reducing the efficiency of the EGR. The post-processing system for exhaust is the DOC and the DPF. The DOC converts some of the harmful substances in exhaust gas into harmless substances. The DPF collects particulate matter in exhaust gas through a filter. When particulate matter are accumulated, the DPF burns them off through a regeneration process. We will now analyze the waveform during DPF regeneration. First, main injection occurs at the TDC when regeneration is not performed. Pilot injection starts right before BTDC-12, and post-injection is not performed. When regeneration starts, the main injection is normally performed at the TDC, but the number of pilot injections is reduced to once at ATDC-27 when the piston is at its downstroke after the combustion stroke, increasing the exhaust gas temperature. Post-injection occurs twice to increased exhaust gas temperature to 550 degrees Celsius to 650 degrees Celsius. The first post-injection occurs during initial regeneration around ATDC-27, and the second post-injection occurs around ATDC-72. The PM accumulated in the DPF is combusted through this process. Note that this result may vary depending on the engine or emission gas regulations. Please review the lessons you've learned in this session through Simple Quiz. Let's wrap up what we've learned today.